So this is our function of vertical order sum, and let's start our code. So firstly, what we'll do, we'll create a queue, and what we have to insert in our queue, we have to insert a vertical pair. Okay, so we need to create a class of vertical here because our queue was containing what, a pair of, our queue was containing a pair of node and a level. So let us create a class. Class name is vPair, and we'll create a node and a level. Initialize with null. And also a level. This is horizontal level. So our class is ready. Okay, so next what we'll do, back in our function, and we'll be creating the range for our width. Okay, so we'll call a function width. See, to find the width of Binarytree, there is a separate question, as I have told you earlier. So we'll not go deep into this function, because if you want to go deep into this function, then watch the separate video of question to find the width of a Binarytree. Okay, so min max will contain what? Min max will contain the range, so it will be of size 2 only. That is minimum range and the maximum range, and out of it we'll find the length, which will be min max of 1 minus min max of 0 plus 1. So till now what we have done, till now we have created a array, we have created a queue, and we have created a queue containing pair of root and level, and we have found the range, and we have found the length. So till now we have done these things. Now what we'll do, we will create a vector array. We'll create a vector of answer. So in C++ we have to create vector, and in Java we have to create array list. So in C++ there is no concept of array list. That is why we are creating the vector. So we will initialize with 0. So we have initialized with 0. And now what we'll do? See, till now we have initialized this vector with 0. We have created the vector and we have initialized with 0. So in case of C++, it is vector. So and now we are going to insert the root in our queue. So we are creating a pair to insert into the queue of name temp containing a pair of root and positive value of min max of 0. That is okay. So now we will insert this into, we'll push this into the queue. Now we will create a while loop. If you are not getting why we are creating this while loop, then I'll be explaining it just right. Okay. If size is not equals to 0, we have to also start one more while loop. Q dot size. See why we are doing this thing. Let's move to our tree. So when we were storing the size of Q, then whatever the was the size, we were iterating over this size and we were checking for the left and right children of it. Suppose the size was 1, then we were iterating for one time. Suppose the size was 2, then we were iterating for every node. For every node. So that is why we have created 2 while loops. Now we will remove the pair from, that is removed pair from Q. Why we are keeping it safe? We are removing but keeping it safe because we will be doing a lot of things from this removed pair. What things? We will be inserting the value of it in our vector and we will be also calling it, we will be also calling its left and right children to check whether they are present. If they are present, then we will be adding its children in our queue. That is why we are keeping it safe. After that, what we will be doing? We will be creating an answer and we will be adding. See, we have created an answer vector here. We have created an answer vector and we will be adding the values of removed pair in our answer along with its level. Not with its level, rather we will be adding at a particular index and that index will be horizontal level of removed pair. We will be inserting the value at this index. Okay. So now we'll check for its left and right children. If they are present, then we'll be adding it in our queue. If it is not equal to null PTR, then we'll be adding it in our queue. So push back. We'll be creating a pair. We are adding a pair in our queue. That is why we are creating. What it will contain? It will contain left value. Value of left children. Okay. And same thing we will do for the right children. So this will be right and then after doing everything we'll return the answer. So return the answer. So till now what we have done, we have almost completed our code. See, we have created the queue and we have called our width function to find the width, and out of that min and max means range, we have found the length, and we have created our answer to store the sum, and we have inserted 0. We have initialized our answer vector with 0, and we have created a temp, and that temp is storing the root value and its level, and that pair is inserted in the queue. So when the root is inserted into the queue, the size of queue is 1. So we will come in the loop, and here we are iterating in the size. So we have removed from the front of queue, and we have stored that removed pair safely to find it, to insert that removed pair value in our answer vector. And also we are using that removed pair for calling its left children to check whether its left children is present. If it is present, then we'll be adding its left children in our answer vector, sorry, in our queue. We'll be adding that left children in our queue, and if we'll checking its right children. If right children is present, we'll be adding its right children in our queue. So let us run our code. So there is some error in line number 22, in line number 21. So there is one more error, returning a non-void 27. Okay. So line number 21 is v pair tree node asterisk node. So this will be A. Sorry, A. So we haven't marked the semicolon here, and let us run now. Okay, so width was not declared in this scope. Okay, so we haven't made the function width. We have called the function width, but we haven't made the function width. So let us make first void width. This will contain and also the answer. Okay, so we are not going, we will be not discussing this width function. I hope you have watched the video of this question to find the width of a binary tree. Then return answer of 0 will contain minimum among what? Among HL, and answer of 0 and answer of 1 will contain maximum range. So maximum of HL and answer of 1. Okay. Now we will make recursive calls, passing root of left, decreasing the HL value and passing the answer. Similar we will do for the right call. Okay. Now let us run our code. So this will be integer. Let us check some errors if there are. So this will be q dot pushback, and rest everything seems to be fine. So this is okay. So it will be v pair. This name is v pair. Okay, and there will be semicolon. Hello everyone, welcome to Pepcoding. So today we are going to discuss the question vertical order sum of a binary tree. So we'll be given a binary tree and we have to print the sum in vertical order. So for detailed information, let's move to our tree. So the question is like, we are given a binary tree and we have to print the vertical order sum. Firstly, to know the vertical order sum, you must be aware of the question how we are going to traverse in vertical order in a binary tree. If we have been given a binary tree, then how we will traverse in our binary tree in vertical order. So for that, you must first watch the video of question traversal in traversing. The question is vertical order traversal. Okay, so question is vertical order traversal in binary tree. Okay, so if you will know this question, then it will be more easy for you to understand and find the sum of that binary tree. Okay, so let's move to our question. So I'm giving a brief intro of the question vertical order traversal. What we used to do in that question. See, if we'll see in this binary tree, then these are the vertical levels. This is the 0th level. This is the 1th level. This is the 2th level. This is the 3th level. This is the 4th level. And this is the 5th level. So vertical levels are 0, 1, 2, 3, 4 and 5. And if we'll see the nodes present in each vertical level, then 0th level has 4, 1th level has 2 and 8. 2th level has 1, 5 and 6. So 1, 5 and 6. 3rd level has 3. 4th level has 7. 5th level has 13. So this is the vertical order traversal of binary tree. Okay, and if we have to find the sum out of it, then what will be our answer? 0th level will have sum 4. 1th level will have sum 2 plus 8, that is 10. 2th level will have the answer 6 plus 6, 12. 3rd level will have 3. 4th level will have 7. And 5th level will have sum 13. So we have to find the vertical order sum. So our answer will contain these values. Okay. So this is all about the question, and now we'll talk about the solution, how we will attain this thing. Okay, so this is 0th level, 1th level, 2th level, 3rd level, 4th level, and 5th level. See, in this question, we'll also take help from one more question. Firstly, vertical order traversal, and the second will be width of a binary tree. How this, see, if you haven't seen the videos of these two questions, then first go and watch these two questions. It will be more easy for you to understand this particular question very well. Okay, so these are the separate questions. You must watch these questions first. Okay, so how width of a binary tree will give us? See, if we'll see in this particular binary tree, then width of this binary tree is how much? 6. How? 1. See, it has 5 vertical levels, and if we'll see the width of it, then width will be 6. How will we find width? See, if we are given a range of 0 to 5 and we need to find the width, then how we'll find? We'll find by 5 minus 0 plus 1. Okay, this is how we'll find the width. So what this width function basically do, this width function give us a range from minimum range to maximum range. Suppose we are at this 0th position. Okay, we are at 0th position. So our next position will be -1, then next will be -2. From right side, it will be 1, it will be 2, it will be 3. So what width of a binary tree will do? This will give us the range from -2 to 3. Okay, so this -2 and 3, this range we'll use to find the width. How? 3 minus -2 plus 1. So this will give the width. Okay, so what is the use of this width? See, if the width is 6, then it means we have 6 vertical traversals. 6 vertical traversals. So we need to create an array list of size 6. Okay, so let us create an array list. One, 2, 3, 4, 5 and 6. The size of our array list is 6. Okay, so now we are discussing the solution approach of it. So, what we'll basically do, we'll implement a queue. What we'll add in our queue? We will add a pair in our queue. How? Let me erase. So this is our queue, and this is our array list. Okay, so we will maintain our sum values in our array list and using the queue. What we'll do in our queue? See, if we have found the range, then we have found the width also. And see, the range is also in negative. This is -2, this is -1, this is 0, this is 1, 2 and 3. So to make it positive, what we'll do? We'll add this minimum value. We'll add this minimum value in each level. So +2, +2, +2, +2, +2 and +2. Okay. So this will become 0, 1, 2, 3, 4 and 5. Okay. So why we are doing this, you will get to know soon. Okay. So firstly, we will have access to our root, and indexing we have done like this: 0, 1, 2, 3, 4, 5. So how we will get access to it? See, we will pass the root value in our function, and we'll add this root value in our queue along with its vertical level. So its vertical level is 2. So we'll add its level. Now what we'll do, if we have added the root value, then the size of queue is 1. Okay, right now size of queue is 1. So now what we'll do, after adding into our queue, we will remove it. See, we'll remove it from queue and we'll add it to our array list of particular index. So our root value is 0 and its indexing is 2. So we will add this 0 at 2th index of our array list. Initially array list is containing zeros all in all the indexes. Now what will happen? We'll add this 0 in the index 2. So we'll add this 0 and the size will become 0. So now what we'll do, as soon as we are removing the node, we'll also add its left and right children in our queue. So left and right children of 0 are, okay, so the value of root is 1. So it's the mistake. So value of root is 1 and I have written 0 over here. So value of root is 1. So 1 will get added. Okay. So now we'll add children of 1 in our queue. Children of 1 are 2 and 3. Firstly, we will add left children and its index is 1. Means to say is its vertical level is 1, its vertical level is 0, its vertical level is 1, its vertical level is 0, its vertical level is 2, its vertical level is 3, it's 4, it's 5. So while we are adding its children, left and right children, we'll also add its right children 3, whose vertical level is 3. Now the size of queue is 2. Now we will access these nodes 2 times. So firstly, we'll access left child. So what we'll do, we'll remove left child, we'll add its value in index 1. So index 1, this is indexing and this is the node value. So we'll add 2 as 1th index of array list, and also we'll add its left and right children. So 2 is having left and right children as 4 and 5. So we will add 4 with its index which is 0th level. Okay, also its right child is 5 with its level which is 2. Okay, now what we'll do, we will decrease the size. Now the size is 1. Next we will access to this node. We'll remove 3 and we'll add at index 3, and we'll add its children. So 3 is having children 6 and 7. Firstly left children, then right children. Level of 6 is 2. Level of 7 is 4. Okay, so now the size, now this size will get decreased. This is 0 and this size is 4. Okay, so now it's the turn for 4. We'll remove 4, we'll add 4 at 0th index, and also we will add its children. So 4 is having children, left children is nothing, right children is 8, and the level of 8 is 1. So now its size will get decreased to 3. Now we will remove 5 and we'll add at index 2 and we'll add its children. So 5 is having children, 5 is having no children, so we will just reduce the size. So now we'll remove 6 and we'll add 6 at index 2, and also we'll add children of 6. 6 is having no children, so just reduce the size. Okay, now we will remove 7 and we'll add at index 4, and also we'll add its children. 7 is having no left children, only right children, so 13 will be the right children. So now 13, level of 13 is 5th. Now the size of will get decreased, and now the size of Q is 2. Okay, so now we will get access to this 8. We'll remove 8 and we will add this 8 at index 1, and we will add its children. 8 is having no children, so just decrease the size, and now we'll get access to 13. We'll add 13 at index 5 and we will add its children, but 13 is having no children, just reduce the size. Now the size of Q is 0. So now we have to do nothing, we have just stored our answer. So this is array list which is containing our answer, and if we'll see level order wise, then 0 will have the value at 0th position. This is 0th position, we'll have the value 4, and at 1th position we'll have the value 10. At 2th position we'll have the value 8. At this position 3, 7 and 13. So we have learned about the approach to solve this question. Now we will implement our approach in our code. So let's move to our code section.